Hey doctor, my name is Faith and this is a demonstration video for my motion control project using the Siemens TIA Portal V16. So this project is to control a simulated conveyor system using the motion control function block. So in this video, I'll first explain my ladder diagram step by step, and then I'll show how each function works through the demonstration later. So I've created a function block called FB positioning axis, and inside this block I've programmed all the motion commands like power on, jog, and positioning. So this is the main program, OB1. I use this function block by creating an instance and I connected it to a data block diagram, data block name db101. So this is the data block, and then so the logic is organized clearly and using different networks from reset, power, drop, and to movement commands and feedback values. So now I'll go through each network step by step and briefly explain what it does and how it control the axis. So this is the reset function. When I press the reset button, it clears any previous errors or active commands. So this ensures the system starts clean before any motion begins. Next will be the axis ready position axis. So here I can check whether the axis is ready. The system must be powered and initialized before allowing any movement. So this check helps avoid accidental motion when the axis is not ready. So when this output is triggered, only the power on will be able to power on. So this network power ons the motor using the MC power function block. Once this block is active, the drive is enabled and the axis is ready to move. Next, this is the homing function. It moves the axis to the 0 or reference position. Homing is important to define the starting point for all positioning commands. And for this network handles jogging, moving the axis manually. So when I press jog forward or jog reverse, the motor moves in that direction and stops when I release the button. So this is useful for small manual adjustment. And for this one, this block runs the motor at a constant speed using the velocity control function. I can set the speed value and the motor will keep moving at that rate until another command is triggered. So, and then next will be the MC relative. This is for relative positioning. It moves the axis at a certain distance from its current position. So for example, if it's at 100 and I set 50, then the axis will move to 150. And next will be the MC absolute. This block is for absolute positioning. So the axis will move to an exact position such as 200 regardless of where it currently is. Next will be the MC hot. This is a soft stop function. When I activate MC hot, the axis decelerates gently and comes to a stop. It's useful for control and smooth stopping. And this is the MC stop. This block performs a hard stop like an emergency stop. The motor stops immediately even if it's running at a high speed. This is important for safety or emergency conditions. And next will be the actual value. This network shows real-time values like current positions, velocity, and speed. This output helps to monitor how the motor is behaving during motion. And next is the standstill. This network checks whether the motor is in standstill condition, meaning it is not moving. This is helpful before issuing a new movement command. And lastly will be the error summary. This network summarizes any error status. If something goes wrong, the system will report the error here. This helps with troubleshooting and ensure safety. So now I'll move on to the simulation. So now I've started the simulation. And before any motion started, power must be on. So now power is in true status. So now we can start the simulation. So first of all, I will show the move relative first. So the distance I've set here for 200. So now I'll start the modify to 1. And it will move to 200 from the original position. And if I modify to 1, it will again add 200 in until 400. So now it has reached 400. Okay, so for the move absolute, I have set the distance here to 5,000. So now I modify it to 1, and it will start it to move the position to 5,000. So now you can see it is moving to 5,000. So let's say I want to halt the position. I'll modify it to 1. It will stop. And then if I want to restart it back, the move absolute, and then I'll modify to 0, and then again to modify it to 1. So it will continue the motion. So now it has reached 5,000. It will show the standstill come true, means that the motor has stopped and the move absolute is done. So let's say I make it back to the home position, so I modify it to 1, and then it will back to home position. And So if I want to move again to the move relative, I just modify it to 1. And then if I want to stop the process immediately, like it's an emergency stop, so I'll modify this to 1 and will stop immediately. So that's all for my simulation video. Thank you.